Hello. In this video, I will be covering stacks and queues in C++, continuing our journey through fundamental data structures. So, what is a stack? A stack is a linear data structure that follows the last in, first out, or LIFO principle. Push means to insert an element at the top, pop means to remove the top element, and top or peek means to view the top element. Examples in real life: a stack of books, or a browser back button history. You could also think of a stack of dishes. So we are in our first example here covering a stack using the standard the stack include, the stack library. As we can see, the C++ STL stack provides push, pop, top, and empty. So first, on line 6, we're defining a stack. Then we're pushing 3 elements onto the stack. So first 10, then 20, then 30. Then we're going to use the top method to see the top. After that, we're going to pop an element, and then we're going to see the top again. And then we're going to traverse the stack by popping all the elements. So let us compile our program and run it. So we can see here on line 13, we print out the top being 30 because that's the last element we push. Then we pop 30 from the stack, leaving 20 to be the top. And then traversing the stack, 20, then 10, then nothing. Again, the stack can grow and shrink dynamically. Elements are removed in a reverse order of insertion. Again, following the last in, first out principle. Let us next look at a stack implementation using arrays. So here we need to define a class called stack. Again, we're using arrays, so we're going to define an array with a max size of 5. We're going to declare an integer called top. That's self-explanatory. And then public, the constructor. Top, it starts with -1 as a kind of a default. Bool is empty. This returns if top is -1. Again, that the default integer. And then Boolean is full returns if top equals max -1, i.e. if the array is filled. So push, again, this is a function here called push. We are inserting an integer called x. If, first of all, before we do anything, if the array is, or in this case, stack is filled, we print out stack overflow in return, and we do nothing. However, if that's not the case, if it's not full, we add x, we push into the stack by assigning the array with a new top value to be equal to x. Pop, real similar. If it's empty, i.e. if the top is -1, we print out stack underflow, i.e. nothing in there, and then we return. But otherwise, we just decrement the top value. Finally, peek. If it's empty, again, you can't do anything. You can't peek anything, so you return -1. But otherwise, we return the top of the array. But again, the implementation here is real simple. We're pushing, again, this is our stack, not the standard library stack called S. We're pushing 10, 20, 30, and then very similar to what we did in the last program's main method. So let us compile this program. Again, the top element is 30 because that's the last element that we push. We pop, and then after that, it is 20. Again, this demonstrates a manual stack implementation. Remember, we have a fixed size here using the define keyword and the max variable. Push and pop now check for overflow and underflow because that's not built in. So moving on to queues. Well, first of all, what is a queue? Well, a queue is a linear data structure that follows the first in, first out principle. So otherwise known as FIFO. Enqueue means to insert at the rear. Dequeue means to remove from the front. And no, I don't mean Dairy Queen, but dequeue. Front is the first element, and then rear is the last element. So examples in real life, basically anything with the word queue in it. So ticket counter, grocery store cashier, or your printer has a queue as well. So what does this look like with the standard library? Well, again, just like stack, it's pretty simple. First, we define a queue. Again, this is the standard library one, or not our own yet. We'll do that in a minute. We're going to call it queue. We're going to start by enqueuing the elements. So pushing 10, 20, and 30. Again, it's also named push, but push means something completely different than in a stack. Then we'll print out the front and rear. And then we will dequeue, so pop. So take the first one out in line, and then we print out the front again. After that, we traverse the queue in a similar format as a stack. We just keep popping the elements, and then we're done with the program. So let us compile this program. And run it. So we can see after we enqueue all three elements, the front is 10 because that's the first one in line, and then the rear is 30. That's the last one in line. Again, completely opposite than a stack. In the stack, the 30 would be the top, but now front is. And then the back is obviously 30 because that's the last one in line. We pop 10 off, and now the front is 20. And then we traverse the queue by popping the elements. So 20, then 30. So again, the C++ STL queue provides push, pop, front, back, and empty. Elements leave in the same order that they entered. Again, the first in, first out principle. For our last program in this video, let's look at an array representation of a queue. Again, just like the array representation of a stack, we are defining a max size, and that is characterized in our private variable array. And then we also need front, rear, and count. So as a constructor, we are defining the front to be 0 because there's nothing in it yet, the rear to be -1, and then the count to be 0. So is empty as fuel is real simple. Is empty returns whatever the result of count being equal to 0. And then is full returns count is equal to max. Enqueue, again, just like push, but here, because we're passing in an integer, if the queue is full, first thing we do is to check that. If that's the case, there's an overflow and we just return. Otherwise, we add or enqueue or push whatever x is to the stack and then increase the count. Also, dequeue, if it's empty, Again, the queue underflow, return, and then actually remove it by simply decrementing the count. Finally, peak. If it's empty, there's nothing you can do. So nothing is done there. But otherwise, we just return the front of the array. And in our main method here, we are defining a queue, our queue, not the standard library, enqueuing 10, 20, and 30 in order, and then checking out the front element, which should be 10, dequeuing 10, and then peaking at the front would be 20, and then we return 0. Very similar to the STL main method. So let us compile this final program and run it. So the front element is 10, and then the front after dequeue is 20. Again, as a final explanation here, we use a circular queue approach with modular arithmetic. We prevent wasted space after dequeues, and we check for overflow and underflow. So some key takeaways before we conclude the video. A stack is a last in, first out principle using push, pop, and top functions. A queue is a first in, first out, or FIFO standard using enqueue, dequeue, front, and rear functions. Both are foundational for parsing, scheduling, graph traversal, recursion, and operating system algorithms. Especially if you've ever worked with assembly, stack is especially important because you have limited registers. But in terms of C++, it provides STL implementations, which we will be using in the future, but I figured it would be important to show a manual implementation for your understanding. If you found this tutorial helpful, do not forget to like, subscribe, turn on notifications, and leave a comment. Please reach out if you have any questions. Otherwise, thank you for watching and have a great day.